8.9 objective, learn to calculate with spheres. Essential question, how do I find the volume and surface area of spheres? We're going to continue by watching a short video about spheres, followed by some examples.
In this video, we are going to learn all about spheres. A sphere is a three-dimensional solid that looks just like this. It's sort of like a three-dimensional circle. Like a circle, it has a center point, and actually every single point on the sphere is the same distance away from this one center point. The distance that every single point on the sphere is away from the center is the radius. Now, if we go all the way across, that's called the diameter, just like in a circle. Now, the sphere has many circular cross-sections, meaning that if you slice a plane through the sphere, you will get a circle in all the different cross-sections. But if that cross-section happens to have the diameter of the sphere in it, then it's called a great circle. So this would be an example of a great circle. So it's the biggest possible circular cross-section that you can get from the sphere. Now, two things that you want to know how to figure out about a sphere are its surface area and its volume. The formulas for both surface area and volume require calculus in order to derive them. So for right now, we're mostly just going to focus on using those formulas correctly. The surface area formula is 4 pi r squared. So you'll notice that the only information you need to know about the sphere is its radius. The volume formula is 4 pi r cubed divided by 3. And again, the only information you need to know about the sphere is its radius. One way to think about the surface area is it's possible to sort of unwrap the sphere and reorganize it a little bit to turn it into a rectangle, where the rectangle has dimensions of 2 pi r, which is the circumference of the great circle, and 2r, which would be the diameter, in the other dimension. And you see you multiply those together and you get 4 pi r squared. Volume is like if you imagine having a pyramid that has this rectangle as the base and then comes up from there with a height of r for the radius, then its volume would be 4 pi r cubed divided by 3. So that's sort of where the formulas come from, but again, you need actual calculus to be able to derive them. So let's say that we had a sphere with a radius of 3 centimeters. If we wanted to figure out the surface area, all we'd need to do is calculate 4 times pi times the radius of 3 squared. So when we do that, we get 4 pi times 9, which is 36 pi centimeters squared. Surface area always has square units because we're thinking about how many squares would it take to cover the sphere. For volume, we would need to do 4 pi times the radius cubed and then divided by 3. So that would be 4 pi times 27, which is 3 times 3 times 3, 3 cubed, and then divided by 3, which also ends up being 36 pi, but this time it's centimeters cubed, because for volume we're thinking about how many little unit centimeter cubes would it take to fill up the sphere.
So let's continue on. If you didn't get a chance to write down the formulas, now's your opportunity. First, the volume of a sphere, 4/3 pi r cubed. The surface area is 4 pi r squared. Let's do some examples. Find the volume of a sphere with radius 12 centimeters, both in terms of pi and to the nearest tenth. Use 3.14 for pi. Volume is 4/3 pi r cubed. The radius is 12. We substitute in, we remember to follow order of operations, so we take 12 cubed first, then times 4/3 to get our answer in terms of pi, and then times 3.14 for a final answer of 7,234.6 centimeters cubed. Let's try again. Find the volume of a sphere with radius 3 meters, both in terms of pi and to the nearest tenth. We have our formula again. The radius is 3. We substitute 3 in, we get 3 to the third power, times 4/3 for 36 pi. 36 times 3.14 is 113.0, if we're technical, meters cubed. Find the surface area both in terms of pi and to the nearest tenth. Surface area is 4 pi r squared. Looking at the diagram, the radius is 3 inches. So we take 3 squared times 4 for 36 inches, or 36 pi inches squared, and we get the same response as last time. The moon has a radius of 1,738 kilometers. Find the surface area both in terms of pi and to the nearest tenth. So 4 pi r squared is our formula. R is 1,738. We square that and multiply by 4 to get our answer in terms of pi. Then we multiply our answer of 12,082,576 times 3.14 for a final answer of 37,939,288.6 kilometers squared. Just more practice on how to use formulas. Make sure your notes are filled out, and good luck with the practice.